Welcome to The Explainer. Today, we're going to pour ourselves a tall glass of science, actually. We're going to uncover exactly what happens behind the scenes to make sure the milk you drink is both safe and nutritious.
I mean, think about it. It's a staple in refrigerators all over the world. We put it in our coffee, our cereal. A lot of us just drink it straight. But have you ever really stopped to think about the incredible amount of testing that every single batch goes through before it even gets to you?
And right there, that's the central challenge, isn't it? Milk is packed with nutrition, which is fantastic for us. But that also makes it a perfect breeding ground for bacteria. And that's why scientific analysis is so critical for public health.
Okay, so let's get right into it. Why exactly does every jug of milk basically go under a microscope? Well, the reasons are actually more complex than you might think. It's this whole multi-layered process. Of course, number one is safety, making sure we prevent foodborne illnesses. But labs are also checking the nutritional value, right? Like the fat and protein content. They're on the lookout for fraud, like someone watering down the milk to make a bigger profit. And they're making sure that dairy farms are following all the right hygiene rules. It really is all about protecting you, the consumer. So how do scientists actually, grade the milk? Well, you can think of it like a report card with some very specific benchmarks that every sample has to hit. Okay, so this right here, this is the A+ student. This is what you want to see for a perfect sample of cow's milk. You've got targets for protein and fat, a specific range for density, that's the specific gravity, which tells you if water's been added. And crucially, those bacterial counts, like the plate count and coliforms, need to be super low. And that last one, the phosphatase test, has to be negative. And we'll get to exactly why in just a minute.
And this is what happens when things go wrong. What's so cool is that each failed test tells a story. Fat content is way down at 2%. That means somebody probably skimmed the valuable fat right off the top. A low specific gravity? The milk has almost certainly been watered down. And a high plate count or a positive phosphatase test? Oh, those are huge red flags for contamination and improper safety procedures.
All right, let's take a little trip into the lab itself and see how they actually get these numbers. I mean, how do you measure something like fat content so precisely and so quickly? Well, one of the most common, a real workhorse of a test, is called the Gerber method. It's a really fast and clever way to isolate the fat. You basically use a strong acid to dissolve everything except the fat, which lets it separate out so it can be easily measured. And to do it, they use this really cool specialized glass tube. It's called a butyrometer. And it's designed so that after everything's separated, you can literally just read the fat percentage directly off the markings on the neck. It's simple, smart, and super efficient. And the whole process is incredibly streamlined. You add your chemicals, you spin it in a centrifuge, which forces the lighter fat to float to the top, and then you just read the result. A test that's totally vital for quality control can be done in just a matter of minutes. Okay, next up is the plate count. A great way to think about this is like taking a bacterial census. It doesn't tell you what kind of bacteria are in there, but it gives you a really good estimate of the total number, which is a direct reflection of how clean the milk is. Now here's the crucial part. What's considered a good number changes dramatically. For raw milk, yeah, a high count suggests poor hygiene. But for pasteurized milk, that number should be incredibly low. We're talking under 20,000 colony-forming units per milliliter. If it's higher, it means either the pasteurization didn't work or the milk got contaminated afterwards. And that brings us perfectly to what is, I would argue, the single most important public health development in the history of our food supply, pasteurization. The goal of pasteurization is actually beautifully simple. Kill the bad stuff without destroying the good stuff. It is a delicate dance of temperature and time, all designed to wipe out harmful bacteria like E. coli while preserving the milk's flavor and nutrition. And wow, has the technology evolved. The older method involved heating a huge vat of milk for a full 30 minutes. But today, most milk goes through what's called the HTST method. That's high temperature, short time. The milk flows through a system that heats it to a higher temperature, but for just 15 seconds. It's way more efficient. So, just how effective is it? Well, proper pasteurization is designed to kill at least 90% of the bacteria in milk. And most importantly, it gets rid of the most dangerous and heat-resistant bugs, like the one that causes tuberculosis. So, remember that phosphatase test from the scorecard? This is why it is so critical. See, phosphatase is an enzyme that's naturally in raw milk, and it just so happens that it gets destroyed at the exact temperature and time needed for pasteurization. So, if the test comes back positive, it means that enzyme is still there, which is proof positive that the milk wasn't heated enough or it got contaminated with raw milk later. It is the ultimate chemical seal of approval.
But applying all that heat, it does more than just kill germs. It also sets off some subtle chemical changes in the milk itself, some of which are, let's say, unintended consequences. It's known as the Maillard reaction. And you've seen this reaction a million times. It's what makes toast brown. It's what gives a steak that amazing savory flavor. Well, in milk, the same thing happens between the milk sugar and the proteins. It can create that slightly cooked flavor, cause a little browning, and it can even slightly reduce the nutritional value.
So processors have to be really careful not to overdo it with the heat. And get this, scientists can actually check on them by measuring a compound called furacine. It's created during that Maillard reaction, so high levels of it are a dead giveaway that the milk was overheated. It's all about finding that perfect balance between safety and quality. So the next time you pour a bowl of cereal or just enjoy a cold glass of milk, you'll know. You'll know about the butyrometers, the bacterial census, the phosphatase tests. It is an incredible amount of science, all working in the background to guarantee that what's in your glass is pure, safe, and nutritious. And it really makes you wonder, what other invisible safety nets are built into the food we eat every single day?